Now let us look at the next question. Show that the vectors A, B and C, they form a right angle triangle. Okay, so you have three vectors, okay, and the three, if taken in proper order, they form a right angle triangle. Now for any three vectors to form a right angle triangle, the necessary condition is that their sum should be 0, and these three vectors, they should not be in the same line. That means they should not be collinear, or they should be non-collinear. Okay, so this is one aspect. Another is this aspect. Now if the two vectors, they are parallel to each other, then let's say vector A and vector B are parallel, then vector A can be written as some scalar multiplication of vector B. Now in these cases, no pair of vector will follow this condition. That means they all three are non-collinear. Okay, I'll give you an example. Let us say vector B is, let us say, given as -6 I cap plus 4 j cap minus 2 k cap. Then this can be written as 2 times of -3 I cap plus 2 j cap minus k cap, and this in turn is equal to vector A. Okay, so vector B is 3 times vector A. So these two are parallel to each other. Okay, now in this particular case, A, B and C, if you look closely, there is no such relationship that is possible. So all the three are non-collinear. Now let us check up whether they meet up this condition or not. A plus B plus C is equal to 0. Vector A, vector B and vector C, they are given as -3 I cap plus 2 j cap minus k cap. B is given as I cap minus 3 j cap plus 5 k cap, and vector C is given as 2 I cap plus j cap minus 4 k cap. Now if we add all the three vectors A plus B plus C, then we'll be getting at as 0 I cap plus 0 j cap plus 0 k cap. That is, it's a null vector. That means the three vectors, they are indeed, they are forming a triangle. Now the condition that we have to prove is that they are mutually the two vectors are mutually perpendicular to each other, or all the three vectors, they form a right angle triangle. Now which two sides they form, the sides of the containing the right angle, that we have to see. Now we know that, let's say these two, this is perpendicular, this is base, and this is hypotenuse. So hypotenuse is always more than perpendicular, is always more than base. So the two sides having lesser magnitude, they should be containing the angle 90 degree. Okay, or they should be mutually perpendicular to each other. So let's say this vector and this vector is there, P and B, then P dot B will be equal to 0. Okay, now how to find out which of the three are perpendicular and base, that we have to see by calculating their magnitudes. So we'll find out the magnitude of A first. So magnitude of A will be given by under root of -3 squared plus 2 squared plus minus 1 squared, which is equal to, now what is this value? Minus 3 is, 9 plus 4 plus 1, which is equal to under root of 14. Similarly, magnitude of b is given by under root of 1 square plus minus 3 square plus 5 square. Now this value will be equal to under root of 35. Now vector c is given by under root of 2 square plus 1 square plus minus 4 square. Okay, so this is 4 plus 1 plus 16, that is under root of 21. Now by applying Pythagoras theorem also you can find out that vector b is the hypotenuse and the other two sides, they are mutually perpendicular to each other, because under root 14 squared plus under root 21 squared will be equal to under root of 35 squared. So this is one way of finding it out. The other way is that we take dot product of a and c. Now we know that these two are mutually perpendicular. So a dot c should be equal to 0. Now let us do it. What is a? Minus 3 I cap plus 2 j cap minus k cap dot product with c, which is 2 I cap plus j cap minus 4 k cap. Now if you do the dot product, minus 3 into 2 is minus 6 plus 2 into 1 is plus 2, minus 1 into minus 4 is plus 4. This is 0. Now it implies that vector A is perpendicular to vector C. Okay, so the three triangles, they must be of this form. Vector A, vector C, this is root 14, this is root 21. Okay, and this is vector vector B, which is root 35. So vector A, vector B and vector C. Okay, these two are mutually perpendicular.